Chapter 4. Weeds of tough grasses. Learning objectives. After study of the material in this chapter, you should be able to 1. Describe cultural management practices that will reduce weed problems in turf. 2. Describe a situation where a broad-spectrum, non-selective herbicide could be used on turf. 3. Explain when weather conditions might cause herbicide failure. 4. Explain how to use herbicides to slow the development of resistant weeds. 5. Identify the best time to control biennial weeds. 6. List 2 summer annual grasses and describe the best time to control them. 7. Describe 3 problems that could cause failure of pre-emergence herbicide. 8. Describe the best approach to control undesirable perennial grasses. 9. Describe the best approach to control yellow nutsedge. 10. Describe the best approach to control winter annuals. 11. Describe the stage of plant growth and weather conditions that favor successful use of post-emergence herbicides. 12. Explain when herbicides can be used on newly seeded areas. Terms to know. Selective herbicide. Non-selective herbicide. Susceptibility. Tolerance. Resistance. Translocation. Germination. Residual activity. Rhizome. Tuber. Pre-emergence. Stolen. Post-emergence. Contact herbicide. Systemic herbicide. Volatilize. Spot treatment. Chapter 4. Weeds of tough grasses. Weeds are plants growing where they are not wanted. Whether a plant is considered a weed depends on personal opinion and the intended purpose of the turf. Before making a weed management plan, the tough grass manager should know the user's opinion about which plants are weeds and how many weeds they will accept in any particular area. Only turf that has great visual importance or requires uniformity for its use really needs to be totally weed-free. For most sites, a practical goal is to keep weeds at tolerable levels. An integrated approach to weed control. Effective weed management takes a season-long, integrated approach. Weeds are not usually the cause of problems in turf. They often appear when turf is already weak or thin. Poor turf conditions where weeds become problems are usually caused by mowing too high or too low and applying too much or too little water and fertilizer. Shade, soil compaction, diseases, and insects also weaken the turf. The first line of defense in controlling weeds is to promote a healthy stand of the desired toughgrass with no bare areas for weeds to invade. A dense stand keeps sunlight from reaching the soil surface and stimulating weed seed germination. If weed seeds do germinate, their leaves will not get enough sunlight for photosynthesis, and the plant will die. To reduce weed problems, follow the recommendations on turf selection, installation, and care outlined in Chapter 2. Cultural practices that help with weed management include planting a turf species that is adapted to the site. Mowing at the correct height. Fertilizing only when turf is actively growing to avoid stimulating weed germination. Dethatching or aerating at times when weed seeds are not germinating. Managing disease and insect pests to prevent thin areas in the turf. Watering infrequently and deeply. Top 10 reasons to control weeds. 1. Weeds compete with toughgrass for light, moisture, and nutrients. 2. Weeds decrease the economic value of landscapes. 3. Weeds damage the appearance of lawns, parks, playing fields, and recreational turfs. 4. Weeds make athletic and recreational turfs slippery and increase the chance of injury to players. 5. Weeds produce large quantities of seeds. 6. Weeds produce pollen that can cause allergic reactions. 7. Weeds become a fire hazard along roads and near buildings when the top growth dries. 8. Weeds harbor pest insects and rodents. 9. Weeds provide a good place for the development of disease-causing organisms. 10. Weeds are sometimes poisonous to people, pets, and livestock. Weeds of tough grasses. Sources of weeds. Turf weeds may be introduced in contaminated seed, sprigs, or sod. Always use high-quality, weed-free seed or sod, particularly to prevent introduction of perennial weeds such as quackgrass and nutsedge species that are very difficult to control. In contaminated topsoil, manure, compost, or mulch. By wind, water, equipment, or animals. Herbicides. You should consider a number of factors before choosing any herbicide. You need to know what weeds you are treating and whether the herbicide is non-injurious to the turf species. Always read the label. Important terms associated with herbicide use are defined in Table 4.1. Table 4.1. Herbicide terms to know. Selectivity. Selective. A selective herbicide controls certain plant species without adversely affecting the growth of a different plant species. For example, a selective broadleaf herbicide kills broadleaf weeds, but does not harm toughgrass. Non-selective. A non-selective herbicide typically kills all plants, weeds as well as desirables. Susceptibility. Susceptible. A susceptible plant is killed or injured by a herbicide. Susceptibility varies among plant species. Check the label carefully for a list of susceptible weeds and for restrictions concerning the use of herbicides on specific toughgrasses. Tolerant. Tolerance refers to the natural ability of a plant to remain unaffected by a herbicide. Weeds that are closely related may differ in tolerance. For example, a herbicide that kills yellow nutsedge may have little effect on purple nutsedge. Resistant. Resistance occurs as populations of weeds become more tolerant of a herbicide as a result of it being used over and over again on the same site. Timing. Pre-emergence. Pre-emergence herbicides are applied to existing toughgrass areas before weed seed germination to control susceptible weeds during the very early stages of germination. Post-emergence. Post-emergence herbicides are applied to emerged weeds. Mode of action. Contact. Contact herbicides kill or injure only the part of the plant that is touched by the spray. Systemic. Systemic herbicides are absorbed by the leaves or roots and circulate within the plant to kill it. Herbicide failure. Herbicides can be the most effective and economical way to control weeds, but using pesticides as the only method of weed control often leads to disappointing results. Unless improvements are made in the management of a weedy turf site, the same types of weeds will come back, or new weeds that are even more difficult to control will show up. If the herbicide application did not control the target weeds, try to figure out why it failed. Application errors are the major cause of herbicide failure, but weather and stage of plant growth may also be factors. Application errors. When the application rate is too low, weeds may be injured but continue to grow. When the rate is too high, particularly with translocated or systemic herbicides, the chemical can kill the leaves before it can be translocated through the plant. Applying an herbicide at a higher than recommended rate also increases the chances of herbicide injury to the toughgrass or leaching into the soil to non-target plants such as tree roots and to groundwater. Remember that exceeding the label rate is illegal. Environmental conditions. The performance of any herbicide depends on the weather conditions before, during, and after application. If weeds are not actively growing because the weather is too dry, too hot, or too cold, they will not absorb herbicide through their foliage or roots and will not translocate it throughout the plant. Pre-emergence herbicides must be rained on or watered in, but too much or too little water reduces their effectiveness. Soil organic matter and clay can tie up certain herbicides and may affect the dose of some pre-emergence herbicides required for adequate weed control. Always operate application equipment carefully and pay close attention to weather conditions in order to prevent particle drift and vapor drift during and after herbicide application. Read the label to see whether certain combinations of temperature and humidity are likely to promote volatilization, a change from liquid to vapor of the chemical formulation that you are using. Herbicide resistance. When the same herbicide is used over and over, weeds can develop resistance to it. When these plants produce seeds, the new generation also shows resistance. You can slow the development of resistance by 1. Making fewer herbicide applications, 2. Using herbicides that have different modes of action, and 3. Mowing to remove flowers before seeds form. Identifying weeds. Weed identification is the first step in a weed management program. Use pictures, keys, and other identification aids. Several common toughgrass weeds are described in this chapter. Weeds are grouped by botanical classification and also by life cycle. By classification or appearance, turf weeds may be grasses, broadleaf plants, or sedges. In terms of their life cycles, weeds may be annuals, biennials, or perennials. Grasses have jointed, hollow stems, parallel leaf veins, and a fibrous root system. Broadleaf weeds have net-like veins in their leaves and usually have colorful flowers. Sedges have a solid triangular stem, and may spread by tubers and rhizomes as well as by seed. Annuals complete their life cycle in a single year. Summer annuals germinate in the spring, then flower, and produce seed in late summer and early fall. They die when the temperature goes below freezing. Winter annuals germinate in the fall, persist in a dormant state throughout the winter, then flower, and produce seed in mid to late spring. They die in hot summer temperatures. A biennial completes its life cycle in 2 years. In the first year, the plant forms a circular, ground-level, basal rosette and develops a large taproot. In the second year, it produces flowers and seeds and dies. Biennial weeds are usually easier to kill in their first year, but their rosette forms are often overlooked. All biennials are broadleaf plants. Perennials can live indefinitely. Depending on the species, they may regenerate from vegetative, non-seed structures such as roots, rhizomes, stolons, or tubers. Simple perennials reproduce primarily by seed, but if weeding severs the taproot, the piece left in the soil can regenerate a new plant. Creeping perennials reproduce vegetatively by rhizomes, stolons, tubers, swollen underground stems, bulbs, and creeping roots. To manage perennial weeds successfully, you must eliminate the underground plant parts. Rhizomes are creeping underground stems and stolons are creeping above-ground stems. Annual grasses. Winter annual grass. Annual bluegrass is a light green bunch type to slightly spreading winter annual. Annual bluegrass is highly invasive and tends to fill in stressed areas of toughgrasses. The seeds sprout whenever moisture is adequate in the spring and fall. Plants develop quickly, often flowering 6 to 8 weeks after germination. Annual bluegrass tolerates poor drainage, compacted soils, and close mowing, but not drought. Some subspecies of bluegrass, which are particularly evident in bentgrass gulf greens, are classified as short-lived perennials. The whitish seed heads of bluegrass are most abundant in mid-spring, but appear throughout the growing season. Figure 4.8. Goosegrass flowers look like zippers. Summer annual grasses. Crabgrasses germinate from March through early May and live until frost in the fall. Both large crabgrass and smooth crabgrass are common and grow best with adequate light and moisture. In August and September, the flowers and seeds of crabgrasses extend like fingers from the tip of a stalk. The leaves of large crabgrass are hairy, pale blue-green, and 2 to 6 inches long. Smooth crabgrass has smooth, dull green leaves 1 to 4 inches long with sharply pointed ends. Young crabgrass lies flat with pale stems branching from the center. Crabgrass becomes upright when crowded. Goosegrass germinates about 2 weeks later in the spring than crabgrass. The stems are pale at the base, and they do not root at nodes like crabgrass. Because it grows flat, goosegrass is a very troublesome weed in athletic fields, golf greens, tees and fairways, and in other tough grasses that are mowed short. In July and September, the flowers occur on 10 to 12 fingers. It prefers full sun and can tolerate poorly drained and compacted soils. Management of annual grasses. Annual grasses are so similar to desirable toughgrass species that control is difficult once they become established. Only a few selective post-emergence herbicides control crabgrass and other annual grasses in certain toughgrasses. Read labels for species. Remember that post-emergence herbicides only control growing weeds and that seedlings are more susceptible to chemical control than mature weeds. Additional treatments may be necessary to control summer annual grasses that emerge after the initial application. More commonly, pre-emergence herbicides are used to control annual grasses. Post-emergence herbicides. Post-emergence herbicides are most effective when weeds are actively growing. Most of the post-emergence herbicides used for control of broadleaf weeds are systemic and are applied to the leaves and translocated inside the plant. They must remain on the leaves long enough for the herbicide to penetrate and circulate, several hours to a full day. If it rains before enough time has elapsed, weeds may not be killed. Post-emergence herbicides work best in bright sunlight, when soil moisture is adequate, humidity is high, and air temperatures are between 65 degrees and 85 degrees Fahrenheit. Using post-emergence herbicides. Do not apply post-emergence herbicides to newly seeded grass until it has been mowed at least 3 times. Wait 4 to 6 weeks before applying herbicide to a newly sodded area. Do not apply when rain is expected. Try to avoid mowing a treated area for at least 3 days after application. Wait 3 to 4 weeks before seeding bare spots left by killed weeds. Do not seed until the area has received rain or irrigation to break down any herbicide remaining in the soil. Using pre-emergence herbicides. You may need to wait 2 to 4 months before it is safe to reseed. Read the label. Do not use a pre-emergence herbicide before laying sod or at the time of toughgrass seeding unless indicated on the label. Do not add a surfactant or wetting agent to a pre-emergence herbicide unless indicated on the label. Wait until after new toughgrass seedlings have been mowed 3 or 4 times before applying a pre-emergence herbicide. Return clippings to the toughgrass area for 2 to 3 weeks after the herbicide application to give time for any herbicide absorbed by the leaves to be returned to the thatch layer and contribute to the chemical barrier. Try to avoid use of pre-emergence herbicide on thin, weak, or damaged turf. Pre-emergence herbicides. Pre-emergence herbicides are applied to the soil 2 to 4 weeks before expected weed seed germination. For summer annuals, make applications in late winter early spring. Crabgrass germinates between forsythia bloom and dogwood flowering, usually when soil temperatures 4 inches deep reach 55 degrees Fahrenheit. A second treatment 8 weeks later may be needed. For winter annuals, applications are made in late summer early fall. Pre-emergence herbicides persist in the soil for several weeks. Most pre-emergence herbicides have little or no effect on emerged weeds. Pre-emergence herbicides must reach the soil surface to be effective. Thick thatch can trap sprays or granules. Some herbicides volatilize or photodegrade, break down in sunlight if they do not move through the thatch and into the soil. To help an herbicide reach the soil, remove thatch or irrigate with 12" of water to make sure that the herbicide moves through the thatch and reaches the soil surface to create a uniform chemical barrier. Perennial grasses. Dallas grass. Dallas grass is a coarse, fast-growing, perennial warm-season grass that produces abundant seeds. Dallas grass can invade landscapes rapidly. If it is not mowed, it can grow to 4 feet high in clumps. The seed stalks are 1 foot or more tall, and the flower head has 3 to 5 terminal branches that open out and then droop. The leaf sheath, often reddish and looking slightly bloated, is somewhat flat and hairy at the base. Although the tillers, shoots do not root at the nodes as crabgrass does, Dallas grass grows faster than most desirable toughgrasses, which increases the need for frequent mowing. Dallas grass produces leaves near the base of the plant on short shoots that form a knotty mass of very short rhizomes. Management. Undesirable perennial grasses are usually the hardest weeds to control. Because perennial grass weeds are so similar to tough grasses, herbicides that kill the grass weeds may also injure the turf. If only small, scattered areas of the weeds are present, it may be possible to remove them by hand weeding or with a golf hole cup cutter. The only effective method of controlling a large infestation of some perennial grasses is to spot treat the infested area with a selective or non-selective, systemic, translocated herbicide. If a large area is infested, complete turf renovation may be the best choice. Before reseeding or resodding a treated area, it may be necessary to wait several weeks after application to allow the herbicide to break down. The residual activity, duration of effectiveness, of different non-selective herbicides varies. A second application of the herbicide may be required for very difficult-to-control perennial grasses. Sedges. Sedges look like grasses, but their stems are triangular instead of round. It is important to know whether a weed is a sedge or a grass because management choices for sedges are different. Some sedges are annual weeds, others are perennial. A troublesome perennial, yellow nutsedge, is most conspicuous during the warm growing season. It looks like a pale green, upright, weedy grass. Yellow nutsedge spreads rapidly in moist soils from rhizomes that produce tubers. The yellow-green leaves are shiny and waxy on top and dull on the backside. The fibrous roots are mixed with rhizomes. The tubers form at the end of each rhizome, and they can persist in the soil for years. The yellowish-brown flowers occur as spikelets at the end of a triangular stem. Yellow nutsedge blooms from July through September. Purple nutsedge looks very much like yellow nutsedge except that the leaves are dark green and less pointed at the tip. Purple nutsedge produces tubers in chains along the length of the rhizomes instead of at the tips. The flower spikelets are reddish-brown or purple. Management. To manage sedges, you need to be able to identify them and understand their biology. Because many sedges can be identified only by the seed heads, which do not often develop when turf is mowed repeatedly, it may be necessary to remove a sedge plant from the managed toughgrass area and place it in a pot to allow seed heads to develop. Most of the sedge species found in toughgrass grown in the southeast are perennials and require persistent control. Unlike perennial sedges, annual sedges do not reproduce from rhizomes or tubers and therefore are more easily controlled. Both yellow and purple nutsedge are perennials that spread rapidly in moist soils from rhizomes that produce tubers or nutlets. Control of sedges begins in the late spring to early summer after maximum shoot emergence, but before new tuber production, May and June. Purple nutsedge is much more difficult to control than yellow nutsedge and requires multiple herbicide applications a year for several years to get control of heavy infestations. Depending upon the herbicide used, repeat applications are necessary every 2 to 3 weeks. Read the label for information on repeat applications. Broadleaf weeds. Summer annuals. Prostrate spurge has freely branched stems that form a mat at the soil surface. The leaves are small 5/8 inch or less, oval, and close to the stem. They may be hairy or have small purple spots. Prostrate spurge blooms from June through October. The flowers are very small and occur in clusters at the bases of the leaves and at the tips of the branches. Seeds of prostrate spurge germinate at soil temperatures from about 60 degrees Fahrenheit to over 90 degrees Fahrenheit. Management of summer annuals. Summer annual broadleaf weeds, depending on the species, can be controlled with certain pre-emergence herbicides applied in the early spring or with post-emergence herbicides applied in the late spring and early summer months. Correct weed identification is critical to selecting the appropriate herbicides. For best results with post-emergence herbicides, applications should be made when broadleaf weeds are small and are actively growing under good soil moisture conditions. Additionally, applications should be avoided at air temperatures above 90 degrees Fahrenheit to lessen the risk of injury to the toughgrass and nearby trees and shrubs. Winter annuals. Common chickweed is a mat-forming winter and spring weed with many branched stems. The leaves are oval. Lower leaves have petioles, upper leaves sit against the stem. The stems are weak and the plants sprawl along the ground as they mature. The white, star-shaped flowers are very small and inconspicuous. Common chickweed prefers cool, moist, shady areas, and it can survive in compacted soils. Henbit is a small mint plant that branches at ground level and grows 3 to 12 or more inches tall. The square stems are green to purple. The dark green leaves are hairy on top with crinkled edges. The lowest leaves have petioles, but the upper leaves attach directly to the stem and may wrap around the stem. From February to June, henbit has 344-inch, purple, tube-shaped flowers in groups just above the upper leaves. The plants die down in summer, and seeds survive to sprout in the fall. Simple perennials. Dandelions are most conspicuous in cool seasons. Seeds germinate in fall, and the new seedling soon forms a sturdy taproot and a flattened rosette of narrow leaves with ragged edges. In fertile soil, the leaves may eventually grow to 10 inches long with jagged lobes pointing backward toward the stem. Every breeze scatters the delicate seeds widely. Dandelions bloom from spring through fall. Plantains are relatively common weeds that reproduce by seeds and by shoots from the fibrous root system. The leaves radiate from a low rosette. The flower stems are leafless and slender with a flower spike at the top. The seeds form densely along the top half of the flower stalk. Broadleaf plantain flowers from June to September. Buckhorn plantain is similar to broadleaf plantain, but the leaves are narrower and have ribbed veins on the lower surface. Buckhorn plantain blooms in the spring. The flower head is much shorter than that of broadleaf plantain. Creeping perennials. White clover produces numerous seeds, but it can also spread by creeping stems that root at the nodes. The distinctive leaf has 3 round, 3/4-inch leaflets that often have a faint, white, crescent mark. White clover flowers from May through September. Each flower resembles a tiny pea flower, but they are found in ball-shaped heads of 40 to 100 white or pink flowers. White clover occurs throughout the growing season, especially in moist, infertile soil. Wild garlic. Wild garlic is a small, dark green, grass-like weed that grows during the winter and spring and then dies down. The leaves are hollow, slender, and almost round. Wild garlic sometimes blooms and produces seeds. It is placed in this section because management practices for wild garlic are the same as those for biennial and perennial broadleaf weeds. Management of winter annual and perennial broadleaf weeds. Mid to late fall and early winter is the best time to use selective, post-emergence broadleaf herbicides for control of winter annual, biennial, and perennial broadleaf weeds as well as wild garlic. These weeds grow actively at this time of year, and a systemic herbicide is readily taken up by the growing weed and translocated throughout the entire plant. This is necessary for complete control. Mid to late spring is the second best time to control winter annual, biennial, and perennial broadleaf weeds, again using selective, post-emergence broadleaf herbicides. The target weeds should be growing actively to absorb herbicides readily. At this time of year, however, a sufficient amount of herbicide is not always translocated to the roots, and some perennial weeds may resprout. Although some pre-emergence herbicides control certain broadleaf weeds, the selectivity of post-emergence herbicides makes them a more common choice for control of broadleaf weeds. Test your knowledge. 1. Herbicides are one tool for managing weeds. B. The best way to control weeds. C. Too dangerous to use in most landscapes. D. Not really pesticides. Answer: A. One tool for managing weeds. 2. Annual weeds are rarely a problem in toughgrass. B. Only grow in the winter. C. Live from 3 to 6 years. D. Grow, flower, go to seed, and die within 12 months. Answer: D. Grow, flower, go to seed, and die within 12 months. 3. Biennial weeds form a rosette of leaves the first year and flower the next. B. Grow, flower, go to seed, and die within 12 months. C. Live 3 or more years. D. Are not a problem in landscapes. Answer. Form a rosette of leaves the first year and flower the next. 4. Perennial weeds. A. Never have seeds. B. Have seeds every other year. C. Can live indefinitely. D. Die immediately when you cut the tops off. Answer. C. Can live indefinitely. 5. Dandelions. A. Reproduce only from tubers. B. Can be controlled only by hand pulling. C. Are summer annuals. D. Have a sturdy taproot. Answer. D. Have a sturdy taproot. 6. Winter annual broadleaf weeds are A. Best controlled in mid to late fall and early winter. B. Best controlled in early summer. C. Best controlled in late spring. D. Best controlled in spring and summer. Answer. Best controlled in mid to late fall and early winter.